Hello, I welcome all of you in my channel Engineering and Info. If you are new to my channel, please subscribe to my channel. In today's video, I will discuss about hypergeometric distribution. So what is hypergeometric distribution? It is a discrete distribution. Okay. So what is now discrete distribution? In which we have the random variable in the discrete form, means the random variable haven't any values with the points. Okay. So discrete and random variables are like 1, 2, 3, 4, 5, like infinite. Okay. So for the most common distribution that is related to the discrete distribution is hypergeometric distribution. In today's video, I will solve an example of hypergeometric distribution, okay, by hand. So what is the hypergeometric distribution? Let's suppose we have a finite population. So in the questions of hypergeometric distribution, we have given some finite population, say 100, okay, that consists of n items. Some numbers say, so these n item, they have some of the defective items, okay. So the defective items are represented by capital D. These defective items, they may be less than or equal to the number of population. Means if they are equal to number of populations, all of the items are defective. If less than, it means that few of the items are defective, they are less than the whole population. Okay, so defective item D of these items fall into class of interest. So we are interested that how many of the items are defective out of the population. A random sample has been selected from the population, means n, without replacement. This is the most important condition, that we will not replace any of the part or product we have taken from the population, and the number of items in the sample fall into that class of interest, and we want to find that the sample we have selected, how many items in the sample D are defective. So X is the number of defective items in. So let's suppose the n represents the whole population. You can say D is the number of defectives in that population. Remember one thing, the D will not be in percentage, okay, it will be a number, and it will be a discrete number because the distribution is discrete. Now we select a sample. So in a sample, it's obvious that few of the parts or items will be picked from the good items and few will be selected from the job. However, it's random, we don't know which of the item is good or which of the item is bad. But however, as it's normal that we will select some of the sample we select, it will contain some good and bad items, in short. Then we are interested at how many of the parts in the sample we have selected are from the bad region or they are defective. So after that, we will discuss that what is the formula for the hypergeometric distribution. So probability of the X random variable, it may be a number of defectives, okay. So 1, 2, 3, and it may be 0, that no defective, is equal to dx. It's a symbol of the factorial. You can solve in the calculator using NCR, okay. So dx n minus t n minus x and divided by n to capital N to small n factorial. So this is the formula for the hypergeometric distribution. I'm going to solve an example. So the mu is the mean of the hypergeometric distribution. It is calculated by some sample size with the number of defectives and the total population size, and then this is the formula for the sigma square. Okay, so we use this model when selecting a random sample of n item without replacement. This is the most important. It's a keyword basically, from a lot of n items. N is the population, of which D are non-conforming, D are defectives. This is the Excel function for calculating the hypergeometric distribution. In this example, it is saying that we have circuit boards. Maybe you can say computer motherboards are produced in a lot size of 20. So 20 is my population, and the boards are accepted in a sample of 3 if all are non-conforming. The quality control inspector says that I will take a sample of 3 from 20 boards that have been manufactured, and if all of them are good, I will accept the whole lot. And if at least one of them will become defective, the whole lot will be rejected. the entire sample is drawn from the lot at one time. At one time means without replacement. No item has been replaced and tested. If the lot contains D is equal to 3, so it is assumed that in the manufacturing during the manufacturing of 20 circuit boards, there will be 3 defective out of 20. But we are interested that the sample we have selected, how many of them are defective in this sample, because this the result of the sample will affect the acceptance or rejecting of the whole population or the whole we have production n is equal to 20. So in this example, what we will solve that if the lot contain D is equal to 3 non-conforming boards, what is the probability of acceptance? So the key point when there is no non-conforming unit, because the line here it is written that all are conforming, it is the keyword, the most important thing. Okay, then D is equal to 3, it is non-conforming boards, it's the most important. So first of all, I'm going to write the data that what data formula is n factorial, r factorial and n minus r factorial. Okay, so I'm going to solve it for the one of the values. You can say for the second one I'm going to solve it. Here 30 will be equal to 3, and rest of all of the values I'm going to calculate it by using the Google Chrome website. So I'm going to the Google Chrome. I will write there 17, then I will write 3 here. I will do the calculation. So the answer will be, answer I have is 680. Okay, for the 73. This has been solved in detail. So I'm going to write the same answer in the sheet there. I will write here 680. Then I will going to calculate it for 23, and same is the case. I will write 20, then 3, then enter the calculate, and it will calculate in a it is 1140. So you can write here in the denominator 1140, and then you can calculate it. So I have calculated, and the answer I have is 0.5965. Okay, so this is my answer. So we have concluded that when there is a population of 20 and there are 3 defectives in that population, and our criteria for the rejection is that there will be no non-conforming allowed, so then the probability of accepting the lot is 59.65%. So we have 59.65% probability that we will accept 3 non-conforming unit, but there will be no non-conforming unit in the sample. I hope you have liked this video. If you have liked this video, kindly hit the like button and subscribe to my channel. If you have any question, my WhatsApp number and my email address has been given. You can contact me anytime. Thanks a lot for watching this video.